Hello everyone, this is Prem and I'm presenting my final term project of Infovis. The dataset that I have chosen for this project is football events dataset that has been sourced from Kaggle.com. Some information about the football events dataset. It consists of information about football games from different leagues of the world, namely the top five leagues. It has more than 9 lakh data points and the dataset is divided across two files. The first file is events.csv, which has a more granular like data that involves events like goals, assists, saves, passes, etc. And ginf.csv or gameinfo.csv, which consists of high-level game data like scores, home team scores, away team scores, etc. What is the aim of the project? As a football fan, I wanted to be more educated about the game. So what things impact the game, how the football has evolved about the years, how the teams are playing, which teams are performing the best and which teams are performing the worst, what is the play style of different teams and vice versa. Uh, so in general, the aim is to get more insights about how uh, football works. So, for starters, there was some statistical analysis done on the data, uh, and it was observed some statistical analysis was done on the number of goals scored by home and away teams, and the chart is before you. So, it was observed that home teams in general score more goals. Uh, whereas away teams in general score less goals. So, as we can see here, probability of an away team not scoring a goal is higher whereas it is not as high in home teams. So uh, it shows that home ground advantage is actually, in fact, a real thing. Uh, the further analysis was the outlier analysis was done on players based on the number of goals that they have scored per season. As we see, the positive outlier range is 8.5 goals, which is pretty low considering all the normal strikers score about 15 goals per season. But by further analysis, we were able to determine that the data is accurate because data not only includes striker, but it also includes midfielders and defenders who score far less goals as compared to strikers. So 8.5 range is okay. Furthermore, some normality tests were done to see how normal the data points were. Metrics like wins, losses, goals scored, conceded, etc., were passed through the normality test, and it was found that these all columns were proved to be normal, as the p-value was seen to be zero except one particular column, which was losses, where the p-value uh, passed the 0.05 range and its value was 0.08, which indicates that even enough evidence was not found uh, to determine if the variable was significant. So, post that, we'll go into visualizations. And how I have visualized is I had certain questions in mind and I've tried to answer them through the different visualizations. So, the first is what period of games are we dealing with? So as we can see, the data set that we have is from 2012 to 2017. Uh, as we can see, in 2012, 2016, the number of game played are fairly even. So we can be assured that bias in data for a particular year is not there. Also, 2017, the number is low, and that is because that is when the data stops and we do not have any further data. So we only have partial data for 2017. The next plot is regarding the game distribution across different countries. How many games were played across different countries, and we wanted to see if again there was any bias for a particular league. Uh, the data shows that it looks fairly even. However, as we can see that the number of games for Germany are less as compared to other countries, and it was later found that The German league only has 18 teams, whereas the other leagues have 20 teams, and hence the number of games played in Germany would be less. So that was answered. Then a very top level question was how many games ended up being draw versus having a win-loss outcome. So these are two plots. The left side plot shows the win versus draw ratio. We can see that 75% of the games have an actual win or loss scenario, whereas only 25% of the games end up being draw. Whereas considering the splits of how the teams win, 46% of the times home team will win the game, whereas only 28% of the times away team will win the game. So that further solidifies that home team advantage is a real thing. Also, very quickly, I was going through the different leagues for different years and wanted to find if there were any outliers present for these percentages. And as you can see, all the pie charts look fairly similar, and there were no significant outliers found. Post that, a question for me was, what were the most common occurring score lines? Uh, so we were able to find that the most common score line was 1-1, followed by 1-0 to home team, 2-1 to home team, 2-0 to home team, and 0-0 draw. Again, an interesting observation was that even 2-0 comes before 0-0, so home teams are very much at an advantage here. Again, this plot was a disk plot that we saw earlier. Uh, we won't repeat that. The next question was, what are the best performing teams? So the teams which have the most wins, and as we can see, the most wins were Barcelona and Real Madrid for 158 and 156 wins, followed closely by Juventus. And that was expected because Barca and Madrid had Messi and Ronaldo at that time. And the number of wins for Bayern Munich, which is 147, is highly impressive as well because they play less games than others because they are in the German league. So that was quite impressive as well. Uh, Whereas Juventus was third, and a graph about the worst performing teams. So the worst performing teams were Groton with two, Cordoba with three, and this um, says a lot that there is a disparity about the quality of teams in the leagues and how good the actual top teams are. While top teams have more than 150 wins, these teams are struggling to get even 10 wins. So that was interesting to see. Uh, then a question arises to compare the play style of the teams and what teams are the most attack minded. As we can see again, Real Madrid and Barcelona uh, come back on top and they have almost similar number of goals, followed closely by Bayern Munich. One particular outlier we saw here was Juventus dropped down a lot. They were third in total number of wins, and for total goals, they are about seven. So this shows that Juventus are a defensive-minded team where they focus more on not conceding a lot as compared to some other teams who focus on outscoring their opponent. So Juventus was an outlier in this case. So talking a little bit about my dataset while being large contained a lot of information which was not required for my project. For instance, a column like player substitution, which denotes the event of a substitution of a player, is basically non-helpful to 99% of the other rows because it will contain not applicable value there. And their dataset had many such columns. Hence, the correct way for me felt to create custom data frames from the dataset. And one such custom data frame is team season data frame, which gives information about a team season and how many wins, losses, goals they scored, etc. Uh, for that particular season. And we were able to gather some meaningful insights from that. Uh, the next plot was a pair plot on the data frame that we saw before. And as we were able to see, uh, there is a strong correlation between goals scored and wins, whereas goal conceded and losses also have a very strong correlation. A surprising fact was goals conceded and goals scored do not have a extremely strong correlation, because naturally you would feel that a team which scores more would be conceding less, but that is not the case. Uh, so for that particular reason, we took a case study of Real Madrid's goals scored versus conceded every year. And as we can see that Real Madrid consistently scores a lot of goals. However, that does not mean that their goals conceded is going down. In fact, the more they are scoring, it looks like they are conceding that much more. So this case study helped in understanding why that trend was present. The next plot shows the average number of wins and losses for teams. So the average number of wins for teams was about 12 range, whereas the losses were about 15 to 16. It was interesting to see that on average a team loses more than they win. The next plot is a QQ plot. So a QQ plot tells us how normal the data is. If the data points remain close to the reference line, the data is quite normal. And as we can see, all four of our columns, except some of the outliers, are quite close to the reference line, and hence, for the most part, they seem to be normal. Uh, and next was an area plot where we have plotted the average number of wins, losses, and draws every year. And we were surprised to find an outlier here. So for 2013 was the only year where number of draws was more than number of wins and number of losses. Except that a number of losses has taken precedence in each of the year. So that was interesting to see for 2013. Whereas another area plot was plotted for which are the top five strikers and how these top strikers are scoring. And as we can see, the top players were Ronaldo, Messi, and few others like Suarez, Benzema. And from the plot, we can see that the green and blue are the most dominant ones, and they are consistently scoring the most goals. And they are, of course, Messi and Ronaldo, whereas some other players are also pitching in their contributions here. So there was an analysis of the top strikers, and this was a violent plot of the seasons of players, how many goals they are scoring. And as you can see, most of the data point lies less than 20. Whereas if we go greater than 30, the contours of violence are not present anymore, and there are only these individual marks present there. And these are the outlier seasons of the strikers, and some of those seasons we saw earlier, and some of those seasons are plotted over here as well. So through swarm plot, we were able to see the top five scorers for every year. And we were able to find about 17 top five scorers were present across the years, and this is the plot for the number of goals. This is the correlation coefficient matrix between wins, losses, draws, goals scored, goals conceded. As we saw earlier, goals conceded and losses and goals scored and wins have a pretty strong correlation in them. Uh, Post that will be coming to the phase two plot. So the main idea behind phase two plots were to let user have more control and have more interactivity with the graph, make them more educated about their favorite teams and their favorite players, and compare their teams with other teams as well. And they should be able to find interesting stats about their players. Not only that, but they should be able to download some of those things. And the app is live right now, and we can actually go and check it out. So this is the app of phase two, which contains some information about the dataset and aim of the project. Uh, the first plot shows some plots about uh, the team seasons and how the team seasons look like. For instance, if we take Real Madrid and 2016, as we can see, the usage of drop down and radio button has been done here, and currently the data set is being updated. The first plot is a stacked bar plot where it shows the number of wins, losses, and draws for Real Madrid in 2016. So as we can see, Real Madrid is a performing team and they have a lot of wins. Whereas this is the number of goals scored and considered by Real Madrid in 2016. So they scored 110 goals, whereas they only considered 34 goals in that season. And we can similarly we can just change the data points and like view results for other teams as well and compare your favorite team to some of the other teams. As we can see, Barcelona had 112 goals and 29 considered, so on and so forth. The next data set is for players, and you can basically enter your player's name and select the years, and you will be able to see the number of goals that they have scored for that year. For instance, if I write Cristiano, so all the players whose names start with Christie, they will be shown here, and their information would be displayed on the graph. Since we want to see Cristiano Ronaldo, we can see his number of goals every year here, and we can eliminate some of the data points, and that way we can also just check it for individual years. So for 2015, that was his speed, where he scored 44 goals, whereas in 16 he scored 33. So here you can compare your favorite players and how they are faring against other players. Usage of text area and checkboxes has been done here. The next plot is a table plot. So for a particular year, if we want to find the players who have scored uh, this amount of goals, we'll be able to see through this. For instance, if I want to see for 2015 who have scored uh, 30 to 45 goals. So we should be able to check that. And as we can see, only Messi and Ronaldo were the players who had scored more than 30 goals. And we can also download this table in form of a CSV here. So that functionality is also provided. So people can compare and check their top players. Um, and the last one is a normality test where we'll be able to see uh, what is the p-values of some of the variables in our data set. And uh, as we can see right now, wins for PS test is giving p-value of about 0.00, which indicates the variable is quite significant. So these were some of the plots in my project. Um, Post that there were some plots which I'll go through quickly in interest of time. A joint plot for goals scored and wins shows a correlation there. A rub plot was formed for uh, what are the number of goals that players are scoring, and we can see that after 30, there are very few seasons in which players have scored more than 30 goals. Cluster map again shows some data about how different values in our columns are related, and this was the cluster map that uh, Hex been again. A goal considered and goal scored was interesting because it does not show a trend in a particular direction. However, we can see that both goals scored and goals considered, the most common values for them are about 40 to 60 range. So that was interesting. And as that will conclude our presentation. We learned a lot about different visualization Python packages through this project, and we learned what are the best ways to handle different types of data and what are the best visualizations that we can use for certain type of data. I also learned that you can create your own data from the existing data set you have to make more insightful analysis, and how interactive we can make our graphs. So that was it for my presentation. Thank you.